Okay, so we are broadcasting now. So we're gonna start. So welcome everybody to our talk on web security fundamentals. So today we want to start you off with some basic questions. Who is basically who would consider themselves a experienced web programmer, not necessarily Python?
Must be experience.
That's a question. Who has experience in web security, or have heard of some basic terms? Okay.
So I'm going to put a few there. Most people know the basics are what's the kind of hands up if you know basic web security. Or do you think you know basic web security? Well, it's basic things like answers, SSL. So the question for this talk is that we can spin through it at whatever speed for the audience. Given there's only 10 people here for the discussion session. Things that are interesting if this stuff's too easy for you. So.
Right. So I don't know if anyone is coming into the Google Plus Hangout.
I'm here.
You here?
Yep. Can you hear me okay?
Are you from India? Where are you from?
在台北。
台北. Oh, hey, 你们好.
你好，大家好。
Hey, Kevin speaks Mandarin too.
非常好，可是我们不可以听他们说，因为一点远。He's a little far from the microphone. Actually, he's quite far from the microphone.
Okay, I'll move up and I'll speak.
Okay, all right. So yeah, come out here.
Join the green podium.
So we're gonna start off. Yeah, your side. So,
okay, so we just
go to that. Go read that. Go read that.
Okay. Sorry,
so don't get confused.
Yeah, so we've got a list of things we're going to run through today. State of web development as it is just now. Things like code injection, sanitizing inputs, some basic things you should know. Some details about cross-site scripting, request forgery, sessions and cookies. Dealing with passwords. Hashes, match, and basic cryptography. It's got for the crowd here, maybe quite simple stuff. And I'm not sure we've got network security.
We have 2 slides.
With 2 slides. Okay, so as I say, give us some feedback. Let us know if you want us to go faster or slower. Focus.
If let me send here, so
sure.
The microphone.
Yeah. Okay. So do you want to take this one? Sure.
Quick question. Is this? Can we share it? Can we find this on Google Docs?
You will be able to find this on Google Docs after the talk.
Okay.
Okay, and just keep going. Yeah.
Yep.
Yeah. Feel free to ask us questions.
Okay.
During the talk.
So common threats, things that you're dealing with. Worms not making the attacks. Very common problem. Very easy to deal with, keeping up to date with your software, but that's one of the most likely things you'll be hit with, and it basically just comes down to laziness. Targeted hacking, very hard to deal with, but you're very unlikely to come across it unless your company's doing something that's particularly making it visible. Malware and end users' machines seems very common these days. I think a lot of recent big cases seem to be coming from that people's machines are getting compromised. Most is only going to affect end user data. It's not going to get you into the core of your system, but can be a launch point to get you deeper into things. Internal threats we're not focusing on. If you're dealing in corporate environments, your biggest problem is mostly people in your company doing something you don't want them to do, and that's most of what security is. But I think the audience we've got here, we're more looking at our own web products online and dealing with consumers or dealing with end users. So we're not focusing on that. And then information leakage, which again we're not really covering. Dealing with sort of permissions models between users. All sites are sharing more data these days. And, chances are you're going to make a mistake and share something you shouldn't. So probably a bigger problem now. Oh, I need to go back to this. Okay.
Yeah.
Okay.
So there are a number of common threat categories, some of which you might have already heard of. So if you're there are simpler kinds of attacks. Most common ones is defacement, meaning if you've done something evil and Anonymous caught you, they will hack your website, change your website to put that guy's face on your front page. Right? That's a Viva Vendetta. That's a symbol. Another type of attack is infiltration. So basically, what that means is that has a little bit to do with data theft and loss too. So basically, someone can inject code into your application, right, and it's just scan through the database and grab all the data out from it. Denial surfers is not something that we application programmers have to worry too much because there's very little we can do. It really has to do with scaling. So that has something to do with system deployment and like how you scale up your website and if you're in a cloud. I mean, Amazon is going to deal with that somewhat, but not entirely. Phishing. It's another very common type of attacks. Usually happens with shopping sites or banking sites, right? So some malicious attacker will send out spam emails to lots of people with a site that seemingly looks like HSBC or Citibank or whatever, but it's actually coming from a different domain from the official bank site. They will typically ask you to input your username, password, just like you would expect your banking site to do. And if you're not careful, you could enter your real banking credentials to a fake site. That's really, really bad. There's another type of attack called pharming, aka DNS spoofing or cache poisoning. What that means, basically it's on network security. It has to do with network security. So basically what it does is somewhere whoever controls the DNS will intercept your request, your DNS lookup, right? And then give back a completely different site that points to a completely different IP from the actual IP that you're trying to have the DNS resolve for you. That is not something that we can do much about. Same thing for DNS hijacking. So there are a set of common security best practices. The most basic one is called principle of least privilege. That has to do with your application and the OS that you deploy your application to. In terms of your application, you really have to, when you design your application, you really have to define what privileges users have to access different parts of your website. For example, right, if you are not logged in, you are not allowed to see your profile or anyone else's profile information. The password, the email, the credit card information, you cannot see that. So that's one thing. In terms of the OS that you deploy to, basically you just have to ensure that the process, the web process that you're running, is not running on root. It has no write access to anything else other than its own user. So usually people will deploy a web process using a www user and www user group, and they only have access to certain folders on the system. You have to, another thing is database too. You have to have a separate database account, a separate privilege for each application, so on and so forth. Defense in depth, so basically that means you have to put many, many layers on of security to secure your website. So in case one layer goes down, you still have another layer to contain whatever leakage happened from the first break-in. So basically, there are 4 goals that you have to do when you're trying to secure your application. The first, you have to prevent it from happening. So you audit your code. Detect, in case something happens, you have to know that it is happening. Contain, when you know it's something that's happening, you have to limit the damage, okay? And recover. When you're done limiting the damage, kicking all the hackers out, you have to recover whatever damage they have done. So that's how you secure your application. Identify and harden your weakest link. Usually that's people, right? Just teach them basic things like, don't just click on any links from the email, right? Always check the domain name, the URL is actually the URL that you want to go to. Right? Don't put any password information. Just don't type any password. Don't sign on to anything that you don't trust. And simplicity. The simpler your system is, the easier to audit and harden. So we're gonna go to web app architecture overview.
Right, let's spin through these. So
yeah.
I've got a couple of slides to get through here, but just changes in web architecture over the years. Security is getting harder, or at least it seems it's getting harder. I certainly think so. I think that's true. We've got a lot more data than we did before. We're trying to work faster. We're being more dynamic. We need to get results out. There's more commercial pressure to be quick. We're now dealing with things like DevOps. Everyone here know what DevOps is? You heard the term before? Hands up if you've heard DevOps before. 3, 4? DevOps, yeah. So there used to be a split between systems teams and developers. And systems teams are the ones that manage the production systems. Developers who make the code and hand it over to systems. Now that's very much becoming the application developers manage the application in production. And there's differences all over with kind of how that's changing. The upshot of that is that developers are handling a lot more of what the systems was used to do with keeping with package revisions. We'll get on to that. In the past, we used to see more things like buffer overflows. There's different types of attacks that we have now, and we're now doing more things like cross-site scripting, code injection. Just different types of challenges that we have. And your number of platforms is now huge. When you make a web application, if you're doing the Unix application in the past, you get a few different vendors, a few different platforms or windows. Now you're doing web applications, and it's just an incredible amount of platforms to deal with. So that's another challenge that you've got on there. So, quick view to web applications, circa early 2000. You've got Apache, maybe CGI. It's not really a web application, it's something pretty crude. Things you're probably caring about there, it's a pretty basic web application. You're probably caring, is your Apache server up to date? Is there a buffer overflow in the kernel that someone can exploit with some network code? Keeping your firewall up to date. Applications were simpler back then. There's different state focuses than what we've got now. Moving to mid-2000s, web applications are getting more mature. People are using frameworks more and more. Sites are getting bigger. And this is looking at, someone that's just starting out. They're going to start with a lot of this to begin with. So I don't know what people were using, say, mid-2000s. Does anyone was doing Python back then? I was working with Zope at the time.
2007, I was using Turbo Gear.
Turbo Gears. Anyone else, anything they were using mid-2000s? What were you running back then? Did you have a framework or something you used, or? Okay, so frameworks are always just starting to come out from Python. There was other things in Java, and there's PHP as well. But generally, your application code is now starting to grow. You've got packages there for your kernel, your Apache, and everything else. You've now also got your application framework packages, and you're having to manage those, and that's beginning to grow. And that's the application developer that's doing that part. So yeah, more complex web framework. You're doing some Ajax, you're doing a lot more dynamic stuff going on there, and your JavaScript's getting a bit bigger. Here's what we've got now. You've got a lot more stuff going on. You've got web application services at the back end. You've maybe got search services on there. You've got NoSQL databases. You've got SQL databases. You've got an incredible amount of packages for your application level. You've got packages for your JavaScript. You've got jQuery, you've got Backbone, you've got Handlebars, you've got all these different things that are in there. You've probably got multiple versions of jQuery, whether you like it or not, because some package you're using depends on some old version, and you need to mix them. You're possibly using like a RESTful API, so you're actually accessing objects directly or more directly than you did before. Does anyone here use some kind of thing? Who here uses Backbone? 2 people. Anyone else use something with Backbone, or do you know what Backbone is? You've got something similar. Okay. So you probably have that talking, and you maybe have a layer that exposes some of your objects or exposes more parts of your system. So there's certainly a lot more surfaces on there that you're talking to. And there's also some external web services. You're maybe actually also communicating with Facebook, some plugins, it does post message. You've got all these different places that are interacting. So yeah, effectively what I said. All of that JavaScript code you've got on the left there, that's also public. In the past, the code you wrote yourself was on your own server, people didn't see it. And I know it doesn't matter for open source, but there's certainly more things out there. So that's a lot bigger than it was before, and it's all in JavaScript. We're going to go and talk about code injection in JavaScript and how that matters. And you've also got all these data sources here. And you can treat someone that's been trusted if you want, the stuff that's coming from the back-end server, but in reality, especially if you're starting to use things like Backbone and you're using your RESTful API, there's a lot of possibilities of people putting data in there that can be used to exploit your system. Either a username, sticking some HTML into that, or so on. Packages and config management. So I'll just get back to that quickly. So you've got lots of third-party code in there. You've got a lot of dependencies. I worked on a project recently that had 90 packages on the application level. That's just inside the Python packages. And then you've got maybe 15 packages in JavaScript there. So there's a lot of different things going on. And your expectation now is people are expecting rollouts to be fast. They're expecting continuous deployment, or the amount of engineering that's going on there to actually get things rolled out is difficult. So dealing with complexity, and the basic things you can be doing, using packaging systems, obviously. Asset management for JavaScript. There is some package management now appearing for JavaScript as well, which is crazy, but that's what's going to happen. Using only trusted sources, making sure you're actually pulling these things, and you're not just pulling something off the internet and running it. At least take something from PyPy or somewhere that you've got a little bit more trusted. If something's malicious there, someone will have seen it. If you're doing 90 packages, there's no way you're auditing all that code. So there's always a risk that someone's going to put something malicious in there. For packages you don't need, don't include them. Try not to get to 90 packages. That's just a bit nuts.
Yeah, if you're just using one function from a package with 30,000 modules, then and if it's open source, the best thing to do is just go to the source code, copy and paste that code, paste it into your own code base instead of requiring that library.
When you're doing this stuff, make sure you do keep an audit trail. And if you're pulling things, I've seen lots of stuff where people have made virtual env. Who uses virtual env? Okay, there's a couple of them. They list package names, but they don't list versions. And when they deploy the thing, it pulls in the latest version, or the latest version they pulled out. You have no knowledge then of if a vulnerability appeared in a third-party package, when that started, and how much your data is compromised. So make sure you're trying to keep an audit trail of stuff, and keeping up to date with security releases, which is difficult. So code execution security flaws. This should be basic stuff to most people. Hands up here, everyone that knows SQL injection. SQL injection? You know what I'm talking about? Anyone else? Who doesn't know SQL injection?
Who haven't heard of SQL injection?
Okay, that's not one.
So
yeah, just spin through it. So everyone knows when SQL injections, you put arbitrary strings in SQL, someone can put something like this. I assume we've all seen the cartoon of little Bobby tables. Yeah. So someone in SQL, they put a quote semicolon, and then they can write their own SQL statement and mess up your database. Dealing with it, use placeholders, use something that's going to escape it, and make sure that input, if it's unsafe, it will escape those characters for you. ORM and query builders, a lot of people are using these days. I'd be surprised if many people aren't. They'll deal with it for you for the most part, unless you're going to have to go and write your own SQL, which you do sometimes, but for the most part, you don't have to care about this. HTML injection. This is something that's analogous. It's very similar to SQL injection. It's also quite difficult. And if you looked back at all those JavaScript code that you've got there, any vulnerability in any of that JavaScript code that you're including can result in HTML injection. And then we'll go on to see why that's a problem, why that's bad. So you can see a basic example here, very similar to SQL injection. Someone's building HTML by hand in JavaScript and injecting it. And I'm sure you can imagine why this is bad. If somehow someone managed to make that string be this, then that image tag that you're building up there is no longer one image tag, it's two image tags. You could insert arbitrary HTML into this code here, and you can see that on the screen. So a more malicious example, if someone set their username to be something like this, and that username is loaded in the system and it's displayed on the page using that code, just very similar to what you've seen before. Anyone that views that page, you're running the JavaScript there. You've taken control of that page, and you can then do whatever you want with the JavaScript on there. We'll look at cross-site scripting a bit later on and show why that's really dangerous. But basically, anyone can run arbitrary JavaScript in your code if you get something like that in there. So prevent the character escaping, quite straightforward. When you anytime you're going to see these HTML entities, you can replace them out. There's different ways to do that. It can get a little hard to manage because you have to know what strings are already escaped, so you don't double escape them, what ones aren't escaped, which ones are trustworthy. Some functions are safe to use, some functions aren't. So if we look at jQuery, jQuery is a particular problem. Most of the methods in jQuery are not safe to pass user input to. And I'm sure if you audit quite a few libraries out there, especially once you're using your own code, you will find some place where someone's using jQuery.append, they're using the jQuery selector, and somehow user input's made it to that level. Now, maybe you don't care about this, but I'm sure you'll find it's in there, and the vulnerabilities stack up. If someone can do that, and they find they can change a username and you're not escaping that stuff somewhere else, then they can get JavaScript onto your page, and maybe from then they can project themselves further forward into your site and start taking the thing over. So there's a couple of safe methods to use there. Text, .atter, you can use those methods safely, but other ones, make sure you're sanitizing your input before you put them in there. HTML templates, probably even better than using jQuery to actually use template language. And I kind of feel like a bit crazy that we've got template language in JavaScript now, but that's, I didn't expect Node.js to exist, and now it does. And HTML templates are there as well. Make sure you use the escaped versions. Underscore, I've noticed the documentation for that. They commonly use the equals version in all their examples. Just make sure if you're using something like that you do the use the escaped version rather than just copy and pasting what's there. Cross-domain security. Okay, so back over there.
Right. So I'm going to talk about cross-domain security. So what I mean by cross-domain security is basically communication between two sites. You think of it that way. So most browsers these days implement a security policy called same origin policy. What that means is that any scripts will only have access to methods and attributes, which includes your DOM methods and attributes from resources that came from the same origin. What same origin really consists of is a tuple of three things: same scheme, same domain, and same port. Okay, so if you look at the left-hand side, all of those things, all of those different resources came from the same origin. They all have the same scheme, which is HTTP, same domain, www.example.com, and the same port, which is by default 80. If you look at on the right-hand side, you see the first one uses HTTPS. That's a different scheme. That's not the same origin. Second one, has a different subdomain, so that's a different origin as well. Third one, different port. Fourth one, completely different domain. So we're going to start into going more in depth in one of the most common attack factors these days. So back in the days, in the early 2000s, I think someone started a project to keep track of common security vulnerabilities in web apps, not your desktop apps, web apps. In the early 2000s, the most common security flaw was buffer overflow. You rarely see them these days. In the mid-2000s, you're starting seeing a lot more SQL injections because obviously a lot of PHP programmers were writing SQL by hand. But they've learned their lessons. Now you have ORMs in PHP, and they're starting to pick that up. So in the late 2000s, cross-site scripting, cross-site request forgery are the main, starting to become a really big issue for web apps, and I'll explain what they are. So cross-site request forgery is basically so back to the same origin policy. You remember this is basically a limitation on the code that's running inside your browser, right? Your script, say example.com, cannot call script, cannot basically open up an iframe to I know, google.com and scrape inside the iframe and find out what's in there, right? The reverse is not true. Where am I now? Okay, yeah, the reverse is not true. Anybody can still post to your server if you're not careful, because obviously you don't know what requests are coming in on the web server. So one of the possible scenarios is this. So let's say you are the webmaster of example.com. You have a resource called user profile that accepts post requests to modify email and passwords, right? So, and then on the right-hand side, you will have a phishing site, evilhacker.org. There's a form in there that posts to your URL, example.com/user-profile, and guess what is in there? It's got a password, right? So if this evilhacker.org is embedded inside some spam mail, right? Some unknowing, naive person gets it, opens that link up, click the form, input their email and password, bam, they've got you. So how do you prevent that from happening? There are multiple solutions. There's a naive solution is to require a user to enter the credentials before allowing them to access the personal info page. I mean, anybody who's implemented a form and how to verify passwords can do this. The disadvantage is it's pretty annoying, and it's not acceptable in the 2010s now because we are all about UX. So there's a second solution, which is use token. So what is a cross-site request forgery?